So last time we were talking about, I think we were talking about conservation of momentum, right? या उससे आगे बढ़े थे हम लोग. Hello, can you hear me? Hello.
Yes.
हाँ, तो बताओ भाई, हम लोग कहाँ तक किया था हमने लास्ट टाइम? अच्छा, वेज वाला क्वेश्चन. ठीक है, याद आ गया. So what I want to do today is take the discussion further. So I told you that you can apply work energy theorem in conjunction with the conservation of momentum, right? So I want to take that one step further, and I don't think we discussed this question. And it is an extension of the same question. ये क्वेश्चन किया था ना हमने, दिस वी डिड, राइट? हाँ. और वी नॉट की वैल्यू कितनी आई थी? एनीबॉडी कैन टेल मी? Such that it
Two
just climbs v naught is equal to
root 2 gr into small m
r
plus capital M upon capital M.
is velocity so that it just reaches the top of the edge. Find, so this is the next part of the question. Find the maximum height reached if velocity is equal to 2v naught. Okay, so that means that I am now giving the particle a velocity of 2v naught. What will be the maximum height reached? हाँ, दोनों लगेगा इस पे. लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम, दोनों यूज होगा. केवल लॉ ऑफ कंजर्वेशन ऑफ एनर्जी से नहीं कर सकते हैं, और केवल कंजर्वेशन ऑफ मोमेंटम से भी नहीं पॉसिबल. बहुत बढ़िया क्वेश्चन. यस. So I'll give you a hint. I will show you guys what is going to happen. So let me just draw the ठीक है. अब क्या होएगा, ये ब्लॉक जो है इसके ऊपर आ जाएगा ऐसे, फिर ये टॉप मोस्ट पॉइंट पे पहुंच जाएगा. But since the initial velocity is greater than the velocity which makes it just reach the top of the wedge, what is going to happen? Since the velocity is greater than the minimum velocity so that it just reaches the top of the wedge, what is going to happen? It is going to go beyond this point. Yes, sir. So, bilkul sahi. So it is going to go beyond this point. Right now it will be a projectile. So let this be the maximum height of the projectile. This is what we want. This is what we want to find out. Any idea how to do it? I will solve this. Okay, I will solve this. Don't worry. Please help me out. कैसे solve करें इसको? अब, if you have understood this up till now that it will become a projectile, it will go in the air, then नहीं ज़रूर, नहीं गलत.
सर टॉप पॉइंट पे वेलोसिटी निकाल सकते हैं.
हाँ, निकाल तो सकते ही हैं, लेकिन हमें टॉप पॉइंट पे वेलोसिटी नहीं निकालना है ना. हमें तो
सर फिर
मैक्सिमम
उसको
हाइट.
इनिशियल वेलोसिटी मान के फिर प्रोजेक्टाइल लगा सकते हैं.
टॉप पॉइंट पे वेलोसिटी निकाल के इनिशियल वेलोसिटी कैसे मान लेगा उसको? जब हम बॉल को फेंकते हैं तो बॉल की टॉप पॉइंट पे जो वेलोसिटी होती है उसी वेलोसिटी से फेंका गया है क्या? नहीं है ना ऐसा. हाँ. नहीं नहीं, 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 नहीं. Listen to what I'm saying, okay? I'm trying to make you understand. I'm not throwing you a challenge कि इसको करके दिखाओ तो मैं मान जाऊंगा, ऐसा कुछ नहीं. I am trying to make you understand the thought process that goes behind doing such questions. In fact, any question in physics. So, work energy theorem is a tool that we are going to apply. Okay? Work energy theorem is a tool that we are going to apply. To apply work energy theorem, you need an initial point and a final point. Okay. To apply work energy theorem, you need an initial point and a final point. So I have drawn many pictures, which you could also have drawn very easily. This is what is going to happen. Out of these pictures, let's call them 1, 2, 3, 4, 5. 5 pictures I have drawn. Out of these pictures, if you want to apply the work energy theorem, which should you take as the initial picture and which should you take as the final picture? Okay, to apply work energy theorem, which should you take as the initial picture and which should you take as the final picture? Initial क्या होना चाहिए हमारा जो कॉन्फ़िगरेशन है सिस्टम का, और फाइनल क्या होना चाहिए? So Zoheb has said 3 and 5. Ishujot has said 1 and 3. Satyam is saying 1 and 5. Okay, और कोई, anybody else? 3 and 5. अभिजीत विश्वजीत बोल रहा है 1 and 5. अबिन बोल रहा है 1 and 5. Okay. So the answer is you can choose any. विश्वजीत ने बोला 3 and 5. The answer is you can choose any. Okay. So 1 and 3 is correct. 3 and 5 is correct. 1 and 5 is correct. The only difference between these choices is the complexity of the calculations. है, बट जस्ट ये चीज याद रखनी है कि जो भी आप इनिशियल पिक्चर चूज करें और फाइनल पिक्चर चूज करें, उसमें बीच में कहीं पे भी देयर शुड बी नो एनर्जी लॉस इन द फॉर्म ऑफ हीट और साउंड और लाइट एक्सेट्रा। अगर नहीं हो रहा है तो आप कोई भी इनिशियल पिक्चर, कोई भी फाइनल पिक्चर चूज कर सकते हैं। इस केस में देयर इज नो एनर्जी लॉस एनीवेयर, there is no sound being produced, there is no heat. Okay, so you can choose 1 and 3, no problems. You can choose 3 and 5, no problems. You can choose 1 and 5, no problems. In fact, I will show you the various things that you have chosen. So first let's take 1 and 3. First choice, initial picture, final picture. Yeah, I'm choosing 1 and 3. Always keep your eye on what you have to find. Never forget that, what you have to find. Okay, so we have to find maximum height reached. We have to find maximum height reached. So if I apply the work energy theorem between 1 and 3, then I will get minus mgr, that is the work done by Earth, is equal to the final kinetic energy, that is half mv square plus half mv square minus the initial kinetic energy, that is half m into 2 v naught square. Now v naught is known to us previously. We have worked out the value of v naught, root 2 gr m plus m upon m. This v that I have written is the velocity of the block, velocity of the wedge at this moment in time. Now, who can explain to me why I have written this differently? ये v मैंने different क्यों लिखा? क्योंकि लास्ट क्वेश्चन में ये v और ये v तो सेम थे, लेकिन अब ये वाला v डिफरेंट क्यों हो गया? Why is it different now? Can you tell me? This is what you have to.
क्योंकि अब वो रिलेटिव वेलोसिटी जीरो नहीं होगा ना।
Very good. Yes.
सर अभी टॉप वन पे वेलोसिटी है इसीलिए।
हाँ बिल्कुल सही। तो जब हम निकाल रहे थे जब हम निकाल रहे थे v naught का वैल्यू, so that it just reaches the top of the wedge. So we agreed that the the relative velocity of the block with respect to the wedge at the topmost point will be zero, and therefore with respect to the ground both their velocities must be same. This is the condition where it just reaches the top, but here it is not going to just reach the top, it is going to overtake it, and therefore we know that at this point this guy will have a velocity v like so, but another velocity v by. Okay? It will have a vertical velocity, and this weird v that I have written, v square is equal to v square plus v by square. Remember that kinetic energy is half m net velocity square. So we are saying that the horizontal velocity of the object is same as the wedge, horizontal velocity of the block is same as the wedge, and the vertical velocity of the block is some Vy. I don't know what that Vy is. Why is the horizontal velocity the same as the wedge? Well, it has to be, अगर ये ब्लॉक का हॉरिजॉन्टल वेलोसिटी वेज से डिफरेंट है तो या तो ये कांटेक्ट छोड़ देगा या ये वेज के अंदर घुस जाएगा। दोनों चीजें नहीं हो रही हैं। इसका मतलब कि दोनों की हॉरिजॉन्टल वेलोसिटी सेम रहनी चाहिए। So let me just rewrite this equation. So this will be equal to minus mgr is equal to half m. Now I'm going to put in the value of this v square plus vy square plus half mv square minus half m2v naught whole square. Right? This is the work energy theorem equation. And now we need to ask ourselves, how many unknowns did I end up with? पहले मैंने क्या डिसाइड किया कि मेरे को वर्क एनर्जी थ्योरम लगाना है। ये कंक्लूजन पे मैं कैसे आया? मुझको पूछा जा रहा है मैक्सिमम हाइट। तो याद है मैंने आपको बताया था कि अगर वेलोसिटी या डिस्टेंस पूछा जाएगा, हाइट ऑफ कोर्स इज अ फॉर्म ऑफ डिस्टेंस, अगर वेलोसिटी या डिस्टेंस क्वेश्चन में पूछा जाएगा then you have to first think of work energy theorem. That must be the first approach. It may be wrong, okay, it may be wrong, it may lead you nowhere, but 99.99% of the cases it will be the correct approach, right? So obviously in an exam or while doing a homework, while doing some questions, you cannot afford to think कि नहीं अच्छा मैं सोचता हूँ पहले कि क्या होगा। No, you can't do that. So you simply apply the work energy theorem. How to apply the work energy theorem? You have to choose an initial configuration and a final configuration. Is the initial configuration and final configuration written in stone? No, it is not. You can choose any. However, your choice will decide on the complexity of the calculation that is going to happen. So there will be a choice which will be least complicated, and there will be a choice which will be most complicated, and there will be choices which will lead you nowhere. Right? For example, अगर मैं 1 or 2 को ले लूँ, it will lead me nowhere. It gives me no uh, information which I can use to find out what is asked. Now you may ask, ये 1 and 3 में क्या special है? How do you know? कि इसमें I will get to know what is asked. Well, if I know Vy, okay, if I know Vy, then I can definitely work out the maximum height attained by the projectile, because Vy is the vertical velocity of the block, right? Can you repeat how 1/2 mv square has come? Final kinetic energy of the system, भाई. Final kinetic
सर
energy
वो
of the
बीच वाला,
system. हाँ,
सर वो वी स्क्वायर नॉर्मल बीच वाला।
कौन सा नॉर्मल क्या बोल रहा है?
सर वो ब्लू से लिखा है ना सर आपने, वो राइट की तरफ उसके।
ये वाला ना?
हाँ
तो ये तो वेज की काइनेटिक एनर्जी है। हमारे सिस्टम में कितने पार्टिकल्स हैं?
2।
तो दोनों की काइनेटिक एनर्जी लिखेंगे ना।
हाँ
ये फाइनल काइनेटिक एनर्जी है दोनों पार्टिकल्स की, और ये इनिशियल काइनेटिक एनर्जी है दोनों पार्टिकल्स की। यहाँ पे +0 है, यहाँ पे +0।
ठीक है।
आया समझ में? ओके। Okay, so again, let me repeat what I was saying. How to approach this problem? मेरे को मैक्सिमम हाइट पूछा गया है, मतलब भी डिस्टेंस पूछा गया है। पहले मैं वर्क एनर्जी लगाऊंगा। वर्क एनर्जी के लिए मुझे इनिशियल और फाइनल कॉन्फ़िगरेशन चूज करनी पड़ेगी। तो मेरे चॉइस पे कॉम्प्लेक्सिटी ऑफ द फर्दर कैलकुलेशन डिपेंड करेगी। कुछ चॉइसेस ऐसी होंगी जो बिल्कुल यूजलेस होंगी। ये चॉइस मैंने क्यों चूज किया? क्योंकि अगर इससे मुझे Vy पता चल जाएगा तो ऑब्वियसली मैं मैक्सिमम हाइट निकाल सकता हूँ, बिकॉज आई नो देन आई विल नो द वर्टिकल वेलोसिटी ऑफ द projectile. Anybody remember what is the height of a projectile? What is the maximum height of a projectile? याद है किसी को? H is equal to what? याद है
U
प्रोजेक्टाइल
square
के
sin
लिए?
square
U
theta
square
by
sin square
2g.
theta by 2g
नहीं, you should always remember it as
प्लस r भी होगा.
Vy square by 2g. यही तो होता है ना, u square sin square theta by 2g.
हाँ
हाँ
सर.
सर.
तो u sin theta क्या होता है? वर्टिकल कंपोनेंट ऑफ
Vertical
वेलोसिटी.
velocity.
हाँ सर.
हाँ. तो अगर मेरे को Vy पता चल गया तो मैं उस फॉर्मूले में डाल के मैं मैक्सिमम हाइट निकाल सकता हूँ. लेकिन अब वर्क एनर्जी थ्योरम लिखने के बाद मुझे एनालाइज करना पड़ेगा कि कितने अननोन्स हैं मेरे पास. लेफ्ट हैंड साइड में कोई अननोन नहीं है, राइट हैंड साइड में ये अननोन है. दिस V is unknown, Vy is unknown, and that's it. There are two unknowns, V and Vy. Okay? V and Vy, two are unknowns. So if there are two unknowns, that means that I need two equations, right? One equation I have written, the other equation I have to get. From where will I get the other equation?
Conservation of momentum.
Conservation of momentum, right? So I go back and I look at the system and I say, oh, in my system there are two objects, the block and the wedge, and there is no external force, absolutely nothing acting along the x-axis, right? There is no friction from the ground. Earth can only apply vertical forces. So therefore, since there is no x component of force on the system, external force on the system, the momentum of the system along the axis will remain conserved, right? So the conservation of momentum gives us initial momentum m into 2v naught is equal to m plus m into v. Please notice there is no appearance of Vy here because of the fact that we are conserving momentum only along the x-axis. So we are concerned only with velocity components along the x-axis. This conservation of momentum along the x-axis will not bother with the velocity along y-axis. Therefore, you will find that this equation is the same for the previous question as well as this question. What is the difference between the previous question and this question? Well, in the previous question, when the block reached the topmost point, its velocity, vertical velocity, was 0. And in this question, the vertical velocity is not 0. But the momentum along x-axis does not care either ways. Okay, it simply says that let's talk only about the velocities along x-axis. So now, armed with two equations, I can do this question. So let me go to the next page. Please take a screenshot. Although I will be coming back to this, but still, please take a screenshot. Okay.
Sir, we can apply conservation of momentum on the y-axis.
No, you cannot, because there is an external force along the
सर वो
y-axis.
अर्थ का एक्सेलरेशन भी
Gravity.
जाएगा ना, ग्रेविटी. हाँ.
तो आप नहीं अप्लाई कर सकते. Okay, so let me just put in the values now. So this will be minus mgr is equal to half mv square, right? And the value of v is how much? V is equal to 2 mv naught upon m plus m. 2 mv naught upon m plus m, right? So let me just write it as 4 mv naught square upon 4m square upon m plus m whole square, right? This is the kinetic energy plus half m vy square. This is what we want to find, plus half m into the same thing, 4m square v naught square by m plus m whole square minus half m into 4 v naught square, right? Okay. सो कुछ अभी तो कैंसिल हो जाएगा, बट अभी मैं कुछ कैंसिल नहीं कर रहा हूँ, because I want to now put in the values. Okay, I want to put in the values of V naught. Okay, so value of V naught हमने पहले कैलकुलेट किया हुआ है, लास्ट क्वेश्चन में कैलकुलेट किया हुआ है, √2 GR m plus m by capital M. So this will be equal to √2 GR, √2 GR, रूट तो रहेगा नहीं, स्क्वायर हो गया, m plus m upon capital M plus half m vy square, right? Okay, एक मिनट बच्चों. So बहुत लंबा हो रहा है यार, करो ना जरा सा. Of half m 4m square upon m plus m whole square 2 GR upon m into m plus m of minus 4m upon 2, right? 2 GR m plus m upon m. What will cancel out? So m plus m will cancel out here. 2 नहीं मेरे 4 से cancel कर दिया. 2 and 2 will cancel out here. M plus m, 2 and 2, 2 and 2. और क्या कैंसिल होएगा?
सर वो कैपिटल एम भी होगा.
कैपिटल एम होएगा, हाँ कैपिटल एम होएगा. स्मॉल एम भी उड़ जाएगा एक एक. Oh, hopefully now we are getting somewhere. Hopefully the thing will be handleable now. You see what I mean? Complexity of calculation. Minus GR is equal to
उससे जीआर भी उड़ा सकते हैं ना.
नहीं GR नहीं उड़ा सकते हैं ना, क्योंकि VY है ना. VY वाला टर्म में GR नहीं है ना. माइनस GR इज इक्वल टू, हाँ ये कर सकते हैं कि GR कॉमन ले सकते हैं.
हाँ सर.
GR कॉमन लिया तो क्या आएगा? 4m स्क्वायर अपॉन m m प्लस m प्लस 4m अपॉन m प्लस m माइनस 4m प्लस m upon m plus half vy square. Oh, please reduce this and tell me. I think we should get something which is very, very manageable. take the LCM as m into m plus n because right hand side में दो टर्म्स है, उसमें नीचे n plus n है और एक में कैपिटल n. If you take the LCM as upon m into m plus n, what are you going to get in the numerator? Well, first term में तो 4m square ही रहेगा, second term में आ जाएगा 4mm, right? Please correct me if I go wrong somewhere. और third वाला जो term है, that will become 4m plus m whole square, which will be minus 4m square minus 4m square minus कितना आएगा 8mm plus half v by square. Am I correct? Please see, बाद में लोचा नहीं होना चाहिए. Am I correct? Hello, am I correct?
हाँ सर.
Now
Yes, sir.
4m square cancels out. अच्छा, अभिजीत ने निकाल दिया है. ये क्या है, vy है क्या अभिजीत?
सर वी स्क्वायर है सर, थोड़ा गलत है, 1 मिनट वापस भेज दो.
गलत ना करना, मैं तो स्लाइड की जगह ही खत्म हो गई यार यहाँ पे.
तो फिर हम m को कैपिटल M कॉमन लेके भी उसको भी निकाल सकते हैं.
एलसीएम फिर कैंसिलेशन, क्या बोल रहा है रजत? ये तो करेंगे और क्या करेंगे. अच्छा, एम भी कैंसिल हो जाएगा. ओहो,
हाँ सर,
वेरी
वाई
नाइस.
सर, वो कैपिटल M जो है ना.
हाँ, ये भी उड़ गया. ओ गुड.
सर ये आ रहा है चैट पे भेजो.
एम नहीं यार, ये बड़ा कॉम्प्लिकेटेड. एम क्या बचा मेरे पास, इसी पेज पे कर रहा हूँ, ब्लू में लिख रहा हूँ. माइनस जी आर इज इक्वल टू जी आर, ऊपर क्या आया, 4 कॉमन आ जाएगा,
-4 कॉमन ले.
-4 कॉमन आ जाएगा. तो लेट मी जस्ट गेट रिड ऑफ दिस जी आर. -4 जी आर, क्या बचेगा ब्रैकेट में?
M प्लस कैपिटल M.
हाँ विश्वजीत, अब सही निकाला. हाँ, क्या बचेगा?
स्मॉल m प्लस कैपिटल M.
ओहो, स्मॉल m प्लस कैपिटल M बचेगा क्या? तो नीचे भी
सर.
तो स्मॉल m प्लस कैपिटल M है नहीं?
हाँ सर, वो कैंसिल हो जाएगा.
कैंसिल हो गया. ओह, वेरी नाइस. Okay, so the complexity is not as much as we imagined, right? So Vy square by 2 would be equal to 3gr. Yeah, and Vy square would be equal to, in fact, let me write Vy square by 2g would be equal to how much? Vy square by 2g would be equal to how much?
3R.
3r. That's it. That is the answer. Actually, it's not the answer. Can you tell me why is it not the answer?
सर प्लस R भी करना होगा.
प्लस आर भी करना होगा, क्योंकि ये जो 3r है वो ये डिस्टेंस निकाली हमने, ये 3r निकाला, राइट? बिकॉज यहाँ से vy कैलकुलेट हुआ है ना, यहाँ से vy कैलकुलेट हुआ है ये 3r डिस्टेंस. सो वी गेट h max is equal to 4r. Is this understood? Anybody not understanding what I have done? See, the principles are very, very simple. You just have to get a grasp on the principles. Once you can successfully write down the equations based on the principle, that's it. Okay, बात तो ये सब
सर
हो रही
आपकी
है तो
आवाज
आपका
धीरे आ
वॉइस स्लो आ रहा है बहुत.
सर आपकी आवाज नहीं आ रही.
हाँ, मैं दूर हो गया था स्क्रीन से, आ गया हूँ वापस. चलो, so now let me choose 1 and 5, right? I think some of you gave me this choice. So first, let me apply the work energy theorem. To apply the work energy theorem between 1 and 5, I must do what? Well, I must be aware of the initial and final velocity, if possible. I must be aware of the initial and final velocities. ये मेरा initial system, ये मेरा final system. यहाँ पे ये जो ब्लॉक है ये हाईएस्ट पॉइंट पे है. हाईएस्ट पॉइंट का क्या मतलब होता है?
तो उसका
वर्टिकल वेलोसिटी जीरो है।
जीरो
वर्टिकल
वर्टिकल
वेलोसिटी,
कंपोनेंट
हाँ, वर्टिकल कंपोनेंट जीरो होगी. नाउ रियल टेस्ट. What can you tell me about the horizontal velocities of the block and the wedge?
सर वेज का वी रहेगा.
वेज का v है, हाँ. फिर ब्लॉक का कितना रहेगा?
सेम रहेगा।
ब्लॉक का सर वही रहेगा सर. ब्लॉक का
बिल्कुल वही रहेगा.
वही रहेगा ना
मतलब
सर.
ये
एक्स एक्सिस
ऐसे है
का
कि
नहीं
हम लोग
अफेक्ट करता है सर
ट्रक के
ग्रेविटी.
ऊपर खड़े और बॉल ऊपर फेंके है वैसे ही
यस
है।
यस.
तो वो एक्सिस को सेपरेटली करना रहता है ना, तो नहीं.
बिल्कुल बिल्कुल, एग्जैक्टली, वेरी गुड, यस. So at the point of leaving the wedge, the horizontal velocity of the block was same as the wedge. Therefore, thereafter, जो भी force लग रही है वो तो y direction में ही लग रही है. Therefore, thereafter, the velocity of the wedge and the velocity of the block will always, the horizontal component will always remain the same. So using this knowledge now, I'm going to apply the work energy theorem. Minus mg h max, work done by Earth, is equal to final kinetic energy. Both of them now have the same net velocity, minus initial kinetic energy, which is this. Okay. Now again, let's see what is the number of unknowns in this equation. I hope everybody has understood this equation. पहले वाले इक्वेशन में मेरे को Vy भी लिखना पड़ा था, क्योंकि जब मैंने ये फाइनल पॉइंट चूज किया तो यहाँ पे V हॉरिजॉन्टल वेलोसिटी थी ब्लॉक की और Vy वर्टिकल वेलोसिटी थी ब्लॉक की. लेकिन जब ये ग्रीन वाला मैंने फाइनल ग्रीन सिस्टम, ग्रीन बबल में जो बनाया है सिस्टम, वो चूज किया है, वहां पे ब्लॉक ऑलरेडी हाईएस्ट पॉइंट पे है, इसलिए उसकी वर्टिकल वेलोसिटी जीरो है और इन दोनों की हॉरिजॉन्टल वेलोसिटी सेम है ब्लॉक और वेज की. तो दिस टर्म ऑफ कोर्स आई कीप and this term I don't need this Vy anymore. Okay. So what are the unknowns that are here? Well, h max is unknown and V is unknown. दो unknown है. Again हमको एक और इक्वेशन चाहिए. अब ये इक्वेशन कहाँ से आने वाली है? Again I look at the green bubbles and I see that there is no external force acting on the green bubble between the initial and the final point. Therefore, the momentum of the system must be conserved along the x-axis. Right? So from the conservation of momentum, then I'm going to get m into 2v naught is equal to m plus m into v. Again, please notice that the horizontal component of momentum or horizontal conservation of momentum gives exactly the same equation as the previous two uh, calculations that we have done, because it does not care about the y-axis at all. Okay, now I put in everything. So minus mgh max is equal to half. Wait, अबे ये क्या हो रहा है? अच्छा है, अच्छा कुछ तो दब गया. Is equal to half m plus m into v square, and again I'll just put in 4m square v naught square upon m plus m whole square minus half m into 4v naught square. Right. And just like before, let's put in all the values. mgh max is equal to m plus m cancel हो गया यहाँ से, तो half into 4m square upon m plus m into v naught square, which we already know is 2gr m plus m upon capital M, minus half into 4m into 2gr into m plus m upon capital M. So now let's see what cancels out. M plus m goes away, 2 and 2 goes away, 2 and 2 goes away. So I can write now minus, एक m भी उड़ा सकता हूँ मैं, एक m यहाँ से उड़ाया, एक m यहाँ से उड़ाया, एक m यहाँ से उड़ाया. Right? So what do I end up with? Let's see. I end up with minus gh max is equal to, यहाँ क्या आएगा? GR अगेन कॉमन ले लेते हैं. GR कॉमन ले लिया, दो ही टर्म्स हैं, दिस शुड नॉट बी वेरी डिफिकल्ट. GR कॉमन ले लिया तो क्या आएगा हमारे पास? 4m by m, राइट, माइनस यहाँ पे क्या आएगा? 4m plus m by m, राइट. g और g भी अब कैंसिल कर सकते हैं हम. तो मेरे पास आया माइनस एच मैक्स इज इक्वल टू हाउ मच? राइट हैंड साइड वाला फ्रैक्शन कैरी आउट करिए, डिनोमिनेटर तो सेम है, क्या हो जाएगा?
minus 4mr by
-4r.
minus 4r हो गया.
H max is equal to, you see what has happened? You see what has happened with this choice of initial and final? This is all that the calculation involved. Okay? This is all the calculation that was there. With 1 and 3, the calculation was bigger, more complicated. So how do you decide? There is no set rule. This is why I keep on shouting, practice. So when you practice a lot of questions, you yourself come to a conclusion कि हाँ यहाँ पे ऐसे करना चाहिए, यहाँ पे ऐसा करना चाहिए. But still, if you want some sort of a thumb rule, then what I follow is that I don't like to have a lot of variables in my problem. So if I choose 1 and 3, I know that I am going to get a Vy as well. Vy has not been asked for. But if I choose 1 and 5, I am automatically going to get in the equation H max, which has to be found, which is what they are asking me, right? So therefore, I will choose 1 and 5. क्वेश्चन का आंसर दोनों से आएगा, लेकिन एक का कैलकुलेशन थोड़ा कॉम्प्लिकेटेड हो जाएगा, एक का कैलकुलेशन थोड़ा सा. चलो, नेक्स्ट पार्ट ऑफ द सेम क्वेश्चन. Yeah, now this time V naught is some velocity. It is not the velocity with which you should project so that it just reaches the top. वो सबब नहीं. V naught is some velocity. Find the final velocities. M and M.
पिछले क्वेश्चन में 3 और 5 लेते तभी भी आता।
पिछले क्वेश्चन में क्या करते हैं?
वो वर्क एनर्जी थ्योरम 3 और 5 के बीच में अप्लाई करते हैं।
हाँ कर सकते हैं, 3 और 5 भी कर सकते हैं।
हाँ सर तभी भी आता।
Yeah, you can try.
सर
हाँ
सर हमें तो इसमें इस टाइप के क्वेश्चन में तो पता नहीं है ना कि ब्लॉक उसको पार कर जाएगा या नहीं करेगा।
नहीं, कुछ नहीं मालूम ना, तब क्या किया जाए?
फिर वो
ये
अभी
तो
भी
हमें मालूम है।
फ्रिक्शनलेस है।
हाँ सर, हाँ फ्रिक्शनलेस। ये तो हमें मालूम है ना कि ऊपर चढ़ेगा उसके।
सर हम ऐसा
हाँ,
बोल
तो
सकते
फिर
हैं
तो डायरेक्ट
ऊपर चढ़
कंजर्वेशन
के
करेगा।
प्रोजेक्टाइल हो
एक-एक
जाएगा और फाइनली तो 0 ही हो जाएगा ना।
एक एक करके बोलो। नहीं, 0 नहीं होएगा, क्योंकि जब वापस ये
फिर
आएगा
भी
ना उसके
हॉरिजॉन्टल
ऊपर,
होगा
हाँ जब वापस आएगा तो दे आर नॉट, इट इज नॉट गोइंग टू स्टॉप। हु इज गोइंग टू स्टॉप द वेज? You can't say that the velocity of the wedge will be 0. To have the velocity of the wedge as 0, you require a force on the wedge on the left hand side, and there can never be a force on the wedge on the left hand side. Only the normal reaction applied by the block on the wedge will have always a right hand component. It will never apply a normal reaction to the left. So finally what is going to happen, I will tell you. This will have some velocity v1, and this will have some velocity v2 assume. खत्म हो गई कहानी, ये रहा. Now can you tell me the final velocities v1 and v2? This is the initial picture I showed you. This is the final picture. अभी तक जो मैंने किया है फिर वही करो, जैसे मैंने किया है फिर से वही करो. ये v1 पीछे की तरफ है या नहीं है मुझे नहीं मालूम है. मैं अपने कैलकुलेशन में v1 को माइनस लेके चलूंगा. अगर तब भी नेगेटिव आया इसका मतलब v1 आगे की तरफ होएगा. So that is not a
वो
problem.
कैपिटल एम का इसलिए हो जाएगा क्या 2mv नॉट अपॉन m प्लस 1
नहीं,
3mv नॉट अपॉन m प्लस 1.
हाँ, नहीं गलत, पहले सही बोला था. Apply the work energy theorem please, which in this case is extremely easy, and then apply the law of conservation of momentum. You will get two equations with two unknowns, v1 and v2. Solving those two equations may be tough. Solving those two equations may be tough for you because you have not seen. देखो, work energy, work done 0, final kinetic energy. हाँ, मैं केवल इतना लिख दे रहा हूँ सर, उसके बाद करो, you do it yourself. मैं केवल ये इक्वेशन लिख रहा हूँ. ये आ गया वर्क एनर्जी थ्योरम का इक्वेशन. अब आगे करिए अपने आप. बताओ भाई।
सर 2 इक्वेशन आ गया बट सॉल्व नहीं हो रहा।
सॉल्व नहीं हो रहा ना, मेरे को लगा
हाँ सर,
सर एक इक्वेशन और लगेगा शायद।
नहीं लगेगा एक इक्वेशन और। मोमेंटम से ये वेदांत, ये देखना डायमेंशनली इनकरेक्ट आंसर है।
सर वो V0
उनका-
V1 प्रोडक्ट में है ना, तो सर सॉल्व करना
हाँ,
है।
मैं उसका
प्रॉब्लम
तरीका
नहीं
बता
है।
रहा हूँ, मैं तरीका बता रहा हूँ, और यही तरीका अगले क्वेश्चन में हमें यूज करना है। सो मोमेंटम में वी गेट प्लस mv0 initial momentum is equal to final momentum minus mv1 plus mv2। ठीक है, let me rewrite the upper equation।
सर एक क्वेश्चन पूछना था।
mv0 square is equal to mv1 square plus capital mv2 square। Right? ये दो इक्वेशन आने चाहिए सबके। If you have come up till this point, your physics is clear. Now it's only a question of maths. It's being clever about maths. So the upper equation I am going to rewrite now as mv0 plus v1 is equal to capital mv2, right? And the lower equation I'm going to write as mv0 square minus v1 square is equal to capital mv2 square. And now I'm going to divide these two equations. If I divide, what will I get on the left hand side? मैं
V0
ऊपर
minus
वाले
V1
इक्वेशन से नीचे वाले इक्वेशन को डिवाइड करना है। v0 स्क्वायर माइनस v1 स्क्वायर अपॉन v0 प्लस v1 इज इक्वल टू v2। तो ये v0 स्क्वायर माइनस v1 स्क्वायर को कैसे लिख सकते हो आप?
V0 minus V1 into V0 plus V1।
फैक्टराइज कर सकते हैं ना अपन। फैक्टराइज
हाँ
करेंगे
सर।
तो एक चीज कैंसिल हो जाएगी, जो चीज बचेगी वो है v0 minus v1। So now you have two equations, mv0 is equal to minus mv1 plus mv2, and the other equation that you have is v0 is equal to v1 plus v2. Now please solve and tell me the values of v1 and v2. अरे पार्थ, कैपिटल एम कहाँ गायब कर दिया भाई? Please solve and tell me the value of v1 and v2. हाँ, अब आ जाना चाहिए। हाँ, so now there should be no problem, right? You'll get the values of v1 and v2, right? Okay. So I'm going to change the slide. I'm going to go on to the next part now. Okay, please take a screenshot. So we have discussed. So we have discussed how to apply the law of conservation of momentum in conjunction with the law of conservation of energy or the work energy theorem, right? हाँ बिल्कुल सही है बात. So now what we want to do is that we want to study or we want to apply these two things in the phenomena of collision. Okay. Now I am this is a big topic, so I'll take it very slowly. But in this topic there is something very easy. So I will finish that today, right? And we will continue our discussion then from the next class.
सर पार्ट टेस्ट में कितना आएगा ये?
जितना मैं पढ़ा रहा हूँ तभी तो मैं करवा रहा हूँ ना.
मतलब आज तक या?
आज तक.
अच्छा, ठीक है सर.
तो ये जो कोलिशन है दो पार्टिकल्स के बीच में, इसका मतलब होता है दैट टू पार्टिकल्स आर interacting with each other. Now this interaction may have contact or it may not have contact. For example, let's say that a comet is approaching the Earth. Okay. Let's say that a comet is approaching the Earth. एक कॉमेट है वो शायद 2029 में अर्थ के साथ कोलिजन कोर्स में है. उसका नाम ए से तो कुछ था बट अब याद नहीं आ रहा मेरे को. So supposing that a comet is on a collision course with Earth, but it does not actually hit the Earth. Okay, it misses the Earth. What will be the motion of the comet like? Well, due to the Earth's gravity, the motion of the comet will be affected. So, comet will go like this maybe. And the Earth's gravity will affect the comet's motion. This in physics is also described as collision. Although there was no physical contact between the Earth and the comet, still this is described as a collision. In fact, if you remember the famous experiment by Rutherford, the gold foil experiment, in which helium nuclei were sent to a thin gold foil, right? And some of the helium nuclei they actually turned back. Some of them they were deviated by some angle. Right? So there was no physical contact between the helium nuclei and the nucleus of the gold atom. No, not possible. It was a force which was applied by the by the gold nucleus on the helium nucleus as the distance between the nuclei decreased, but the distance between the nuclei never became zero. Okay. So collision is basically interaction of two particles. Having said that, the collisions that we will study will be those in which physical contact does happen as per our observation. Okay? तो जो हम derive करेंगे वो यहाँ पे भी applicable होएगा जहाँ पे physical contact नहीं हुआ, लेकिन जो मैं questions दूंगा maximum हम physical वाले ही collisions की बात करेंगे. Okay? But I just wanted to give you a heads up that collision does not always have to mean that there will be contact between the two colliding objects. Okay? So when we talk about collision, we like to classify collision, and we can classify collision in two different ways. नहीं, contact between forces नहीं कह सकते. Force थोड़ी ना contact करती है एक दूसरे. एक टेंशन दूसरे टेंशन को हाथ मिला रही है और क्या हाल है आपका, और नहीं, ये सब नहीं होता. So there are two ways of classification of force of collisions. Classification of collision का मतलब होता है कि हम describe कर रहे हैं कि हाँ बिल्कुल सही. यस, हम डिस्क्राइब कर रहे हैं कि ये कोलिजन कैसा, what is the content of the collision. We just want to give an overview, brief overview before we carry out the mathematics. So we can classify the collision based on the behavior of energy during the collision, or we can classify collision based on the direction of velocities. Okay. So these are the two types of classification that we are going to do. So what happens basically during a collision, that I will show you later. But for the moment, what is going to happen is that two objects, they are going to come into contact with each other, and because of this contact, their velocities are going to change. Now, why should velocities change on contact? Okay, अगर मैं किसी को थप्पड़ मारूंगा, तो why should the velocity of my hand change, and why should the velocity of that person change जो मार खाया है? So the moment my hand comes in contact with the person I'm trying to hit, there will be a mutual normal reaction which will be generated between the two surfaces of my hand and the person who I am hitting. The normal reaction on my hand will affect the velocity of my hand, and it will change the velocity of my hand from a high value to a low value. It will stop my hand. Okay? नहीं तो मेरा हाथ पता चला उस आदमी के थ्रू चला गया, फिर बहुत गंदगी हो जाए, हॉरर मूवी हो जाएगी फिर तो. So my hand will stop because of this normal reaction, and because of the normal reaction being applied by my hand on that person will accelerate forward. Okay, right? That person will accelerate forward. So when two objects come into contact during a collision, the normal forces between their surfaces are the forces that are going to be responsible for the change in velocities of the two objects. Okay. So the direction of normal reaction, I'll write it here. The direction of normal reaction between the two surfaces is called the line of impact, or LOI. So we will define something called the line of impact as the direction of normal reaction between the two colliding objects. For example, if we have, supposing, a billiard ball moving with some velocity and it is hitting another billiard ball which is kept stationary, right? Then in the future, what is going to happen is that this billiard ball on the left is going to come into contact with the billiard ball on the right, and it is going to apply a normal reaction on this ball, and this ball will apply a normal reaction on this ball. And because of the normal reaction on the blue ball, its velocity will decrease, and because of the normal reaction on the right wala black ball, its velocity will increase. Therefore, after the collision, we will find that the incoming ball has less velocity and the outgoing ball has greater velocity, right? And this is what really happens during a game of snooker, billiards. We can also say that, look, this ball is moving with some velocity v, and this time it is striking a ball which is smaller in radius. So in this case, this smaller ball will experience a normal reaction like this, and this larger ball will experience a normal reaction like this. right? The vertical component of the normal reaction on the larger ball may be greater than mg, maybe, and that will make the bigger ball bounce. It will make it go up. It will make it leave the surface. Okay, ये आया समझ में? ये जो नॉर्मल रिएक्शन मैंने बनाया है, it is just the common tangent basically. It is just the common tangent बोल रहा हूँ, common normal when they come in contact with each other. So we define velocity, we define collisions as head-on or oblique. We define them as head-on if all velocities are along the line of impact. And we define an oblique collision if all velocities are not along the line of impact. Okay? अगर सारी velocities collision के पहले, सारे objects की velocities collision के बाद, सारे objects की velocities सब line of impact के along हैं, तो इसको हम head-on collision बोलते हैं या one dimensional collision बोलते हैं. और अगर कोई भी velocity, एक भी velocity अगर हमारे line of impact के along नहीं है, तो हम इसको oblique collision बोलेंगे या two-dimensional, three-dimensional collision बोलेंगे. So can you tell me, out of these two collisions, are both head-on, are both oblique? One is head-on, one is oblique. क्या है यहाँ पे? Remember, the black arrow is velocity and the green line is the line of impact. Ha, Vijit, very good. Yeah. So the first collision is a head-on collision. Yes, first collision is a head-on. Look at the velocities of the billiard balls after and before the collision. They are all along that same green line, right? So therefore, that is a head-on collision. And the second one is oblique. Second one is oblique because the velocity of the ball is, having a different direction as compared to the line of impact, which is here, right? So there is an angle between the velocity, initial velocity of the ball and the line of impact. So this would be classified as an oblique collision and this would be classified as a head-on collision. अब जब collision होता है, right? जब collision होता है, so what happens is that kinetic energy is converted into potential energy. Okay, where is this potential energy stored and how that happens, I will tell you later on. But kinetic energy is converted into potential energy, and when the collision stops, that means the collision is over, by that time the potential energy is converted back into kinetic energy, right? So I'll send you a video, a YouTube video where you can see this, where they have recorded in slow motion the collision between two objects, and when that happens, irrespective of how hard the objects are, in fact I'll tell you now, irrespective of how hard the objects are, it turns out that during collision all objects will deform. They will lose their shape, whether it is a cricket ball being hit by a cricket bat, whether it is a golf ball being hit by a golf club. टेनिस बॉल तो खैर हम विजुलाइज कर ही सकते हैं कि वो डिफॉर्म हो रही है बिकॉज ऑलरेडी वो इलास्टिक सी होती है. सो व्हेन द cricket ball comes into contact with the cricket bat, the surface of the cricket ball actually deforms as well as that of the bat. Okay? हाँ, मेटल होएगा तब भी डिफॉर्म होगा. तो ये जो डिफॉर्मेशन होता है, basically what is happening is that because of this deformation, the intermolecular bonds of the ball or the bat, they are being compressed, right? I mean, when the ball was manufactured, when the bat was manufactured, the interatomic distances between the molecules or the atoms of, हाँ कोई फर्क नहीं पड़ता सत्य में उससे, डिफॉर्मेशन में बी लार्ज में बी स्मॉल. अगर एक प्लास्टिक बॉल डायमंड की बॉल को हिट कर रही है तो डायमंड में जो डिफॉर्मेशन होएगा वो नेग्लिजिबल स्मॉल होएगा, प्लास्टिक में बहुत ज्यादा होएगा. So the ball when it is manufactured, the bat when it is manufactured, then it turns out that the intermolecular distances, they are at a very optimum level, right? In fact, any object that is there right now in front of you, the interatomic distances are at a very optimum level, and the interatomic or the intermolecular bonds, they behave like little teeny tiny springs. So if you were to try to reduce the distance between the atoms or molecules, the bonds would sort of repel this, the bond would sort of resist this, and they would try to take the molecules back to the normal distance. And if you were to increase this distance, again they would try to oppose this, and they would try to bring the two atoms or molecules back to their optimum distance. So when the deformation of the cricket bat and the cricket ball takes place, it is these little springs, if you can visualize in your head, which get compressed. Therefore, the kinetic energy is being converted into potential energy. But the deformation has a limit. Okay, so the bat and the ball, they keep on deforming, they keep on, and I'm talking about a very small interval of time. ऐसा नहीं है कि विराट कोहली जो है छक्का मार रहा है और हम देख रहे हैं, ओ देखो डिफॉर्मेशन हो गया, ओ देखो. नहीं ऐसा नहीं है. You can't see. It will be too quick. So when the process of deformation starts, kinetic energy starts getting converted into potential energy, and this potential energy is stored in the little teeny tiny springs, that is the interatomic bonds or the intermolecular bonds in that object. So this deformation has an upper limit. Okay, this deformation has an upper limit, and when this upper limit is reached, then the springs in the two respective bodies, they start to again stretch themselves, they start to again go back, they start to fight against the compression. And we say that the process of reformation has started. So all collisions involve a process of deformation and then a subsequent process of reformation. Okay, and when this reformation happens, when this reformation occurs, then the potential energy is converted back into kinetic energy. Now, it may happen that all of the potential energy is converted back to kinetic energy. That's a very nice scenario. But generally what happens is that some of this potential energy remains as potential energy. That means the deformation never ever goes back. Or some of this potential energy is converted into sound energy. Some of it is converted into heat energy. Sometimes some of it is converted into light energy, right? So in that case, the potential energy is not fully converted back to kinetic energy. And we can actually have a classification of collision based on this behavior of energy. And we can call a collision elastic. Okay? We can call a collision elastic if all kinetic energy is conserved. That means that kinetic energy before the collision is equal to the kinetic energy after the collision. There is a better definition, but I will not discuss this today. I'll discuss it later. For now, it is sufficient that all kinetic energy is conserved. That's an elastic collision. And then it is an inelastic collision if kinetic energy is not conserved. Okay, right? And a subset of inelastic collision is something called a perfectly inelastic collision. Can you guess what this will be? A perfectly inelastic collision. Elastic would be an ideal that does not really exist in real life. What would be a perfectly inelastic collision? A perfectly inelastic collision would be
kinetic energy 0 होगा.
नहीं, zero कभी नहीं हो सकती है kinetic energy when none of the potential energy is conserved. When none of the potential energy is converted back to kinetic energy. Okay, that means deformation से reformation होगा ही नहीं. Okay? Deformation से reformation होगा ही नहीं. And this is roughly what would happen if you were in an accident. Hopefully never. But if two cars collide or if two trucks collide, then the uh, then the then you can say that it is almost perfectly inelastic. Okay, so based on this, what we will do is we will say that look, नहीं chemical reaction की हम नहीं बात कर रहे ना. Based on this, what we will say is that look, this is a ball of mass m1 moving with a velocity v1, ball of mass m2 moving with velocity v2. They collide, and after the collision, the ball of mass m1 is moving with velocity v1 prime, and the ball of mass m2, permanent deformation. Yes, बट वो परमानेंट डिफॉर्मेशन मैक्सिमम डिफॉर्मेशन होना चाहिए ना. ऐसा नहीं है कि थोड़ा सा भी डिफॉर्मेशन हो गया तो वो इनइलास्टिक कोलिजन में चला जाएगा. परफेक्टली इनइलास्टिक मतलब मैक्सिमम डिफॉर्मेशन हुआ, वहां से कुछ वापस ही नहीं आया. इट्स लाइक हिटिंग, आई डोंट नो, हिटिंग क्ले. क्ले को आपने हिट किया कहीं पे तो क्ले जो है वो डिफॉर्म होके चुपचाप वैसे ही पड़ा रह गया. दैट वुड बी परफेक्टली. For us in problems, it is very easy. Two objects stick together after collision, perfectly inelastic collision. I'm only talking about head-on. I'm only talking about head-on. So, I want you to do this now. This is what we did in the last question. The last question was actually set up for this only. Find V1 prime and V2 prime if collision is elastic. Okay, so apply the law of conservation of energy, apply the law of conservation of momentum, and you should end up with the same two equations that you ended up in that previous problem. And then I showed you how to solve how to get rid of the quadratic thing. Do that, and then tell me the answer. नहीं Satyam, they will not exchange velocities, no. हाँ मतलब हाँ v प्राइम का मैंने एरो बनाया हुआ है. हाँ भाई हुआ वर्कआउट नहीं हो रहा है. So basically you just need to work out this once. उसके बाद से कभी नहीं. M1 V1 plus M2 V2 is equal to M1 V1 prime plus M2 V2 prime half M1 V1 square plus half M2 V2 square half M1 V1 prime square plus half M2 V2 prime square. Rewriting the above equation as M1 V1 minus V1 prime is equal to M2 V2 prime minus V2, and the rewriting the second equation as M1 V1 square minus V1 prime square is equal to M2 V2 prime square minus V2 square. Dividing the two equations, we get V1 plus V1 prime. This is after factorization. I've cancelled out the term. Is equal to V2 prime plus V2. So now what I can do is I can combine this guy with this guy to find the values of v1 prime and v2 prime. Let's do that. I'm going to change the slide. Okay, please take a screenshot. I'm going to change the slide.
सर एक बार रिपीट कर सकते हो, मैं डिस्कनेक्ट हो गया था।
क्या चीज?
सर वो सेकंड इक्वेशन वाला बता दोगे एक बार?
बस डिवाइड किया मैंने, एक कंजर्वेशन ऑफ मोमेंटम है, कंजर्वेशन ऑफ काइनेटिक एनर्जी है। m1 वाले टर्म्स एक साथ किए, m2 वाले टर्म्स एक साथ किए और डिवाइड किया, और जो क्वाड्रेटिक वाला टर्म है उसको फैक्टराइज किया, तो v1 प्लस v1 प्राइम ब्रैकेट v1 माइनस v1 प्राइम आया, और उसको जब डिवाइड किया है तो v1 माइनस v1 प्राइम कैंसिल आउट हो गया।
हाँ सर, समझा। थैंक यू सर।
Okay, so now let's then take this calculation forward and let's write that v2 prime is equal to v1 plus v1 prime minus v2, right? So we get m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime, which will be m2 v1 plus m2 v1 prime minus m2 v2. Okay, I'm going to rewrite this equation as m1 plus m2 into v1 prime. इसको मैंने लेफ्ट हैंड साइड में लिख लिया, राइट हैंड साइड में क्या आने वाला है, तो ये वाला टर्म और ये वाला टर्म हम दूसरी तरफ ले जाएंगे, तो we will get m1 v1 plus m2 v2 minus m2 v1 plus m2 v2. Right, and now I can rewrite this as, मैं v1 वाले टर्म्स अलग से लिखना चाहता हूँ, तो मैं लिखूंगा m1 minus m2 into v1 plus 2m2 into v2, right? And this is equal to m1 plus m2 into v1 prime. So v1 prime will be equal to m1 minus m2 upon m1 plus m2 into v1 plus 2m2 upon m1 plus m2 into v2. Right, now put this value of v1 prime, either put it here if you want, or you can put it in the conservation of momentum wala equation, or you can take out the value of v1 prime from here and put it in the conservation of momentum equation, and then please tell me the value of v2 prime. And when you find the value of v2 prime, you should see a very nice pattern. वर्कआउट करो ना, अभी जितना पता चलेगा ना। हाँ मतलब
सारे वेरिएबल चेंज हो गए m1 m2 में और v1 v2
हाँ
में।
हाँ so it will be a symmetric kind of a result. So you will get something like 2m1 upon m1 plus m2 into v1 plus m2 minus m1 upon m1 plus m2 into v2. Right, so now things become very easy. You don't have to do this again. If I say that there are two objects colliding with each other, उनका mass इतना है, initial velocity इतनी है, all you have to do is feed it into this formula, and that's it. That will give you the final velocities.
सर मास सेम होगा तो एक्सचेंज हो जाएंगे ना वेलोसिटी?
हाँ, mass same होएगा तो velocities exchange हो जाएंगे. If you put m1 equal to m2, तो आप देखो v1 prime equal to v2 आ जाएगा और v2 prime equal to v1 आ जाएगा. So when masses are equal, velocities they get exchanged. Okay. चलो, I'll stop here. ये फॉर्मूले के एप्लीकेशन से ज़्यादा आपके टेस्ट पे कुछ में आएगा, इससे पहले का ही आएगा. Okay, so I will see you in the next class.
सर वो m2 minus m1 हो जाता है सेकंड.
m2 minus m1 हो जाएगा. हाँ, जो नीचे वाला है वो m2 minus m1. You have to be careful about that, नहीं तो साइन गड़बड़ हो जाएगा. ठीक है, और किसी को कोई स्क्रीनशॉट लेना है रिकॉर्डिंग में ले लेना. दिस आई हैव डन. दिस इज द क्लासिफिकेशन वाला. ये हमने जब लास्ट पार्ट किया था इस क्वेश्चन का, जब हमने 1 और 5 चूज किया. हाँ रजत, मैं अभी बोल दूंगा, आज शाम तक अपलोड हो जाएगा. और ये जब हमने 1 और 3 चूज किया था. और चलो गाइस, सो आई विल सी यू इन द नेक्स्ट क्लास. ठीक है, चलो बाय बाय. आई विल एंड द मीटिंग. राइट, इसके बाद कुछ नहीं है ना?
नहीं है सर.
नहीं है सर.
नहीं है सर कुछ भी अभी.